Hello again. We're back with lesson 11, dividing radical expressions. Now, there is one definition you guys have to know whenever you do division of radical expressions, and it's this. Okay, if you have the square root of a, or let's say nth root of a, because it doesn't really matter, as long as the roots match. Okay, so a square root, cube root, fourth root. If you have that, then you can write it as one big complete fraction. Okay, so that's the definition. Now you can also go backwards, just so you know. So if you have one big fraction inside of a root, then you can break it apart if you want to. Maybe that'll be beneficial. Who knows? But you can break it apart. Okay, so it works both ways. Okay, it works both ways when it comes down to it. So remember, you can divide radicals, you just basically combine them together. Now that's if they have the same index. That's the most important thing. Okay, if they don't have the same index, then you have to rewrite them as rational powers. Okay, so if they don't have the same index, you must rewrite them as rational powers. So let me put that down here right here, because it's kind of like a hint. If they don't have the same index, then rewrite the terms into rational powers. Okay, so if they don't have the same index, put them into rational powers. All right, and that's going to happen in one of, I think, one or two of our examples. So we're also going to learn about conjugates, but we'll talk about that in a bit. Okay, so here we go. Example number 1. So these first 3 examples are going to be the same type of problem. Okay, but they're just going to want us to simplify. So and sometimes they'll tell us like, okay, don't simplify, rationalize, or something like that. Okay, so we'll see, but we'll start off very easy. Radical 50 divided by radical 2. Now notice how they both have the same index, right? It's square roots for both of them. So what I'm going to do is I'm going to combine them into one big square root. And 50 divided by 2 is 25, and the square root of 25 is 5. So there you go. That's a pretty quick and easy problem. No big deal. Okay, so I can get two things on a fraction and put them together as long as they have the same index. Okay, so again, index is the number here. Now, if you don't see it, that means that it must be a number 2. Okay, if you do see it, it's going to be a 3, 4, 5, 6, 7, 8, etc. All right, let's try part B. So in this case, radical 3 over 7, they did give us a fraction inside of a radical. So what we can do, since we can't really divide that, is we can split it up. Like maybe this will help. But in doing that, it doesn't really help. But there is something they always tell us, right? They always say no radicals in the denominator. Right? They always say don't leave radicals in the denominator. So what did we do if we had radicals in the denominator? We would rationalize. Okay, what rationalizing means is you take that term on the bottom, so the radical 7, that's what's causing the problem, and you're going to multiply the top and bottom of that first fraction by the thing that's causing the problem. So the radical 7 is causing the problem. So radical 3 times radical 7 is radical 21. Radical 7 times radical 7 is radical 49. Now radical 21 does not have a nice answer, but radical 49 is 7. Now that we don't have a square root in the bottom, so perfect. We did exactly what we had to do. We rationalized it. Okay, so If you're stuck with the square root in the denominator, you have to fix it by rationalizing it. So here's the last example for example 1. Radical 3z divided by radical 5. Now, I can try to combine these into one fraction and make it 3z over 5, but that's not really going to help me. So what I'm going to want to do is rationalize this problem. So the thing that's causing the problem is the radical 5 on the bottom. So what I'm going to do is multiply top and bottom by radical 5. Okay, so this is radical 15z, because 3 times 5 is 15, so 15z over radical 25, right? 5 times 5 is 25, and the square root of 25 is 5, so this is radical 15z divided by 5. Now, I have had students tell me, hey, Mr. V, why don't I reduce that? 15 divided by 5 is 3, right? I can reduce it. You cannot, because the 5 is not inside of a square root. If the 5 was inside of a square root, then you can actually divide them. But since it's not, you have to leave it alone. So here's that answer to that problem, part C. Now, sometimes, I told you guys earlier, if the indices do not match, you have to rewrite the problem. Let me show you some examples like that. Okay, so this is going to be example number 2. Simplify. And we'll start off with, I guess you could say, an easier one. The 6th root of a times the 4th root of a to the 3rd. Now, we did mention before when we did multiplication of radicals that you can only multiply if they have the same index. These do not have the same index. One of them has an index of 6. The other one has an index of 4. That's not the same. So since they don't have the same index, then I'm going to have to rewrite this as a rational expression. Now, I do want to remind you of something. If you have n radical x to the m, kind of like what you see right there, okay, then you can rewrite it as x to the m over n, okay? So that's the way you're going to write your fraction. All right, so make sure you guys kind of remember that. I'll put a little dashed box around it because it's not a new topic. This is something we talked about before. So here we go. So a to the, this is a first power, so it's going to be a to the 1/6 times a to the 3/4. Now notice these do have the same base, okay? Their base is identical here. They're both a's, so that means I can just add the powers. So this will be a to the 1/6 plus 3/4. Okay, now I'm going to do this by hand, but again, you guys please feel free to use your calculators. They have a 12 in common, so I'm going to make that a 12. That's going to be a 2 12s and a 4. Nope, I'm sorry. Not a 4. That's a 9 12s. Okay, so that would be a 9 12s. So 2 plus 9 is 11. So this equals a to the 11 12s. Now, I'm not sure if on ALEKS they'll let you use that as an answer, but if they don't, I'm going to put or, they might want you to write it as a radical. So the 12 is the index. So 12th root of a to the 11th. Okay, so it's going to be any one of those as your solution. Okay, so there's one. I'll show you one more like this, and then we're going to move on to conjugates. So part B, let's do square root of x y to the 6th divided by 4th root of x y squared. Okay, now for this one, you're going to have to remember a couple of different things. Okay, a couple of different things. We are going to have to remember this property. Okay, the one that we had written earlier. X to the m over n. We're also going to have to remember this property. So, how can I write this? X, y to the m is the same as x to the m and y to the m. We're going to kind of work this a little backwards. Okay, so since this is an index of 2 here, okay, then I can rewrite this as follows. Xy to the 6th, okay, and then an index of 2, a square root is a half power. And I'm not sure if you guys knew this before, but a square root is a half power. If you have a cubed root, that's a 1/3 power. A fourth root is a 1/4 power. Okay, so let's make sure you guys know that, because that's actually pretty important for this problem. And I think we talked about this before earlier in the year, but just in case we don't remember, then it's good that we just kind of review that. The next one is xy squared to the 1/4, right? Because the fourth root is a 1/4 power. Now, because of this right here, I'm allowed to distribute this half and this 1/4 to both terms. So let's go ahead and do that. That's x to the half. And then this will be y to the 6th to the half divided by x to the 1/4 times y squared to the 1/4. All right, now remember, powers to powers, I multiply, right? So 2 times a quarter, 6 times a half. So let me write that out. X to the half, y to the 6 times half, that's 3. And then x to the 1/4, and then 2 times a quarter, that's a half. So y to the half. Now, we're back to some other properties, okay? Whenever you divide x to the m over x to the n, we get x to the m minus n, right? We did that a while back. So x to the half divided by x to the 4th, that's x to the half minus a 4th. And then y to the 3rd divided by y to the half, that's y to the 3 minus half. So half minus a quarter is a quarter, so that's x to the 1/4. And then 3 minus a half, well, that's 2.5, or 5 halves. So y to the 5 halves. Now that's a perfectly good answer. Or if they want you to write it in terms of radicals, x to the 1/4, that's a 4th root of x. And y to the 5 halves, that's a square root of y to the 5th. Remember, the power, the 5 is the power and the 2 is the index, right? So that's why I wrote it like that. So either answer should be good. Now this one was kind of complicated, okay? So I do know that it's not like the easiest one to do, but we did just use properties of things that we have already done. So this isn't like, oh my gosh, this is all brand new, I've never seen it before. You have seen it. You've actually practiced it. If you look back at your, I think it was section 6 or 5, something like that, somewhere around there, you guys had these properties for radicals, okay? So please make sure you guys take a look at those. Now, the last thing, okay, we're going to put simplify by using conjugate. Now, before I do these, I just want to make you recall, okay? So a conjugate, if you have a plus b, then the conjugate is a minus b. Okay, or if you have a minus b, then the conjugate is a plus b. All right, so when we say multiply by the conjugate, you're going to multiply by the same thing, only you're going to change the sign. Okay, so instead of a plus, you multiply by a minus, etc. Now, you only change the middle sign, not the ones in the front of the other numbers. So just the sign in the middle. So let me show you what I'm talking about. So we'll start with something, I would say that's relatively easier. Maybe not, maybe it is, we'll see. But 2 over 4 plus 3 radical 2. Okay, now there's not much you can do with this, but you know the rule. We cannot leave it like that. We got to get rid of that square root. So to get rid of the square root, we're going to multiply by the conjugate of what we see in the denominator. So notice the conjugate of 4 plus 3 radical 2 is 4 minus 3 radical 2. Okay, so there's the conjugate. I'm going to go ahead and multiply. Let's start with the 2. 2 times 4 is 8. Minus 2 times 3, that's 6 radical 2. So far so good, no big deal. For the next ones though, I'm going to have to use first, outer, inner, last. We're going to have to FOIL. Okay, so let's get 4 times 4 and 4 times 3 radical 2. So 4 times 4, that's 16. 4 times negative 3 radical 2 is a negative 12 radical 2. And then let's do the 3 radical 2 times 4 and the 3 radical 2 times a negative 3 radical 2. So let's see. 3 radical 2 times 4 is a positive 12 radical 2. And then 3 radical 2 times negative 3 radical 2 is a negative 9 radical 4, right? Because 2 times 2 is 4, 3 times 3 is 9. I want you guys to notice the middle terms. They should cancel, and they will. Negative 12 radical 2 plus 12 radical 2, they're going to go away. So those cancel. So let me write this out. 8 minus 6 radical 2 divided by 16 minus 9 times 2, right? 9 times 2, because square root of 4 is 2. Well, that's 8 minus 6 radical 2 over 16 minus 18. 16 minus 18 is a negative 2. So, and then I can simplify, guys. Okay, you can simplify this because you're basically saying I'm going to divide all the numbers on top by a negative 2. So this will become a negative 4, a positive 3, and you cannot reduce inside the square root. Okay, so you got to leave it like this. So that's going to be your answer. Now, I'm not sure how Alex is going to want you to leave your answers. I'm pretty sure it's going to be the way I did it there, but maybe it might want that one on top. Kind of look to see what they're giving you to fill out. But I think it's going to be the one that I left for you guys. Okay, so there's one of them. Let's do another one here. I want to do 3 total of these, and then we'll be done. So 4 over 2 plus 5 radical x. So again, you can't really simplify this thing, but you can get rid of the radical on the bottom. So 4 over 2 plus 5 radical x, and then times the conjugate, so I can get rid of the square root on the bottom. So there we go. Okay, so 2 minus 5 radical x. So let's multiply on top. Usually that's the easy part. So 4 times 2 is 8 minus 20 radical x. Then we're going to divide by, all right, we're going to have to FOIL again. Okay, so 2 times 2 and 2 times negative 5 radical x. We're going to do that first. So 2 times 2 is 4. 2 times negative 5 radical x is negative 10 radical x. And now let's do the next part, 5 radical x times 2 and 5 radical x times negative 5 radical x. That's going to be next, the one's in purple. So 5 radical x times 2 is a positive 10 radical x. And then 5 radical x times a negative 5 radical x is a negative 25 radical x squared. Now again, notice this is going to cancel out. Negative 10 radical x plus 10 radical x, that's going to go away. So this will be 8 minus 20 radical x divided by 4 minus 25. Now the square root of x squared, well, we've learned that if the index matches the power, then you just basically get rid of the square root and you write x. In this case, there's not much more I can do. I can't really simplify anything, so I'm done. There's my answer for part B. Now one more, and then we'll be finished. And I know this is kind of a long lesson compared to the other ones we've done, like 3 or 4. I've only been like 10 to 15 minutes or so. But we are going to be done after this lesson, and then we have one more, lesson 12, and that'll finish up the month for you guys. So lesson, sorry, not lesson 12, part C says radical 5 plus radical 2 over radical 5 minus radical 2. Now we can't just cancel stuff out here, okay, because a plus or minus means that if you want to get rid of radical 5 or radical 2 on top, then that means you have to get rid of all of it, and we don't have matching parts. So we're going to just basically do a conjugate, okay? So radical 5 minus radical 2. So we're going to multiply by radical 5 plus radical 2, because that's the conjugate to the denominator. Okay? So that's the conjugate to the denominator, so that's why I want to multiply by that. Now, first off, let's go with the top part, okay? We're going to have to FOIL. Radical 5 times radical 5, and then radical 5 times radical 2. So that's radical 25 plus radical 10. Okay, so radical 5 times radical 2 is radical 10. And then we're going to go with these two. So radical 2 and radical 5, that's going to be a plus radical 10. And then radical 2 times radical 2 is a radical 4 divided by, now we're going to do the same thing again. We're going to multiply here. Okay, so radical 5 times radical 5, that's a radical 25. Radical 5 times radical 2 is a positive radical 10. Now we're going to continue. So negative radical 2 times radical 5 is a negative radical 10. And then a negative radical 2 times a radical 2 is a negative radical 4. Okay, notice on the bottom, maybe it didn't happen on top, but on the bottom, they are going to cancel out. Anytime you multiply by a conjugate, you tend to get the middle disappearing. Okay, so there we go. Let's see, square root of 25 is 5. Radical 10 plus radical 10, that's 2 radical 10. Plus the square root of 4 is 2. Radical 25 is 5 minus radical 4 is 2. Let's continue working here. 5 plus 2 is 7 plus 2 radical 10 over 3. And that's my final answer. So hopefully this stuff makes sense for you guys. It's not anything that seems like it's too difficult. And as usual, please let us know if you guys have any questions. I hope you guys have a great day.